Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of writing recursive sequences. This is standard A.12D in the great state of Texas, and we are using item number 9 of the 2018 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a sequence of numbers, and we need to find an equation that can be used to find the nth term. Now, here's the tricky thing with this sequence, right? We're not starting with 0, we're not even starting with 1, we're starting with the third term in the sequence. And so we're going from, the third term is 0, the fourth term is 6, and the fifth term is 12, and so on. It seems like, all right, we could just add 6, right? 0 plus 6 makes 6. 6 plus 6 makes 12, 12 plus 6 makes 18, 18 plus 6 makes 24. And we're looking at a plus 6, we look at B, we're like, okay, maybe that works. But you know what? It doesn't quite work. It's not that easy, right? So let's plug in this first sequence right here. Okay, so if I plug in 3, then that's the third term, right? So a to the 3 equals negative 18 and then times n, so that's the third one, right? Plus 6. It's supposed to give me 0. But look what happens here. So we've got negative 54 plus 6. So that's going to equal negative 48. Okay, so this, even though we do get a plus 6 right there, that's not the best way to represent this because this is supposed to be 0. And we're not even anywhere close. So that negative 18 times the n, really throwing us off. So let's look at it this way. Okay, so let's look at it. We've got a table of values. Let's just say, all right, our third number is 0. Our fourth number is 6. Fifth number is 12. And our sixth number is 18, seventh number is 24. Okay, so if we were to graph this, and let's just arbitrarily say, all right, you know what, those are my x values, those are my y values. Well, look what I would get. Okay, so I would get an x-intercept right there, 3, 0. Right, 4, 6 might be kind of like this. 5, 12. Might be kind of like this, so on and so forth. You know what? That looks linear. And if it looks linear, well, we know what a linear equation looks like. Y equals mx plus b, which is, that's actually the form this is in over here. Y equals mx plus b, okay? So, if the best way to represent this is with a linear equation, we need to find the m, we need to find the b. Okay, so m, your slope, remember it's your change in y over the change in x. Well, look, every time that we go up 1 for the x, we're going to go up 6. Okay, so we go up 1, we go up 6. So that's pretty easy. So my slope is 6. Now I need my y-intercept. Well, I could just extend this backwards. So if my x is 2, then that's going to be a negative 6. Right? If my x is 1, that's going to be a negative 12. And then if my x is 0, that's going to give me my y-intercept. I'm looking for that point right there. Well, you notice I'm just subtracting 6, right? It still follows that plus 6, but I have to kind of do it in reverse to kind of get where I need to. It's going to be that minus 18, which means that's my b, that's my y-intercept. So I can put those two together with my m of 6, and I can say, all right, a to the n, because that's going to be that's my y right there, is going to be, my m is going to be 6, and then it's going to be a minus 18. It's going to be a plus negative 18. Same difference. My answer is C.